Women coding, women coding community have a very ambitious goal to put at the forefront women to thrive in technologies. And we want women to excel. We want women to not just programming, but also join this field to be on the forefront, which is mean our mission is to give you as much as possible education, access to mentors from the industry, and anything that could support you to rise in the industry. We really want to see you here. We do workshops, events, a lot of educational programs. We connect our members at conferences, and we foster a very supportive community in our Slack. So you are very welcome to join our Slack. And also you can ask questions there. You can ask if you're stuck, if you really feel that you need support right now, just send a message in Slack. We have code of conduct, of course. If you join our Slack and you're a member of our community, be careful and in 2 words, please be nice to each other. And if you see something went wrong, please do not hesitate to contact directors, leaders. You can find contact details on our website. And yeah, this is 2 words about this. Have a lot of projects. We have so many of them, but we don't run all of them at the same time. I need to improve the slides, but our core projects is mentorship program. We also have book club. Every month we explore some books, and this course was actually initially book club, and we tried 2 sessions, and still people said like, can we please do more sessions on this book? And that's how this course, this program appeared. And then we really liked it. I'm doing it for the second run this year. And I hope to give even more insights for design patterns program for this year. Yeah, so this is kind of our study group today. We also had Lead Code study group last summer, and you can find all recordings, and we have a channel dedicated to coding tasks. So if you'd like to ask any questions, you also can post message in this Slack group. We also can organize mock interviews. For this, you need to join our Slack again and ask for anyone who can help you to prepare for interview. And we have a lot of members who have experience and who can help you as well. In the past, we did also cloud track, machine learning track, and system design track last summer as well. We're going to see if we will relaunch them. However, you can find a lot of resources on our YouTube. And this is also your point to start. And to run all these programs, to connect people at events, at conferences, we need more people to volunteer for us. We also have open source project, which is our platform and which is our website. So if you would like to learn new language, for example, you're a backend engineer and you want to try front-end, and vice versa, you front-end engineer, you want to try backend, this is a very good opportunity to contribute in the real project in our platform that's hosting our website. So we have front-end, and this is our website. We have backend, everything open sourced. You can find a lot of details how it's done with our GitHub. And we are very welcome if you would like to join and contribute to our platform. So our platform, very interesting point to volunteer for our community. Also, we're always happy to have volunteers to organize events, to help host online events like today. It's very small things that you can do for us to contribute in our programs. And a lot of other things. If you're curious what's happening in the industry, you can help us to run our newsletter. If you would like to do more writing for blog, you can help us to leverage our community blog. So a lot of things where you could just try some things that you would like to try, but volunteer for us. And we have benefits for volunteers. So as I said about conference, we first of all prioritize our volunteers. We recently got very few seats for very impressive program speedmasters to run startups, and we prioritize our volunteers, of course. If we have any other partnership with these paid programs, we prioritize our volunteers. So our volunteers can get a lot of access to things that they wouldn't get without being volunteers. So I hope that's motivating, but also it's a part of all of this. You can practice with your skills. Again, something you'd like to try. You can just go to the community and say, like, okay, I want to try it. Right now, it's hyping with AI and automation and a lot of things. You also can come with the idea like, hey, I would like to learn these tools, but also help community to do X, Y, and Z by leveraging some AI or MCP. So please welcome. We would be happy to go through this journey with you as well. And that's how you can learn. Another thing that maybe you would like to improve your leadership skills. You want to drive some projects. That's also in coding community volunteering here for you. You can join and say, I want to ownership this thing. And we have projects that we would like someone to own. So yeah. And apart all of this, when we connect online and when we connect in person, it's unforgettable emotions. And I hope if you joined us for the first time today, you will be very happy after this time. Yeah, so thank you so much. Thank you so much for joining. And here is a link to go to our Slack, but also if you go to our website, Women Coding Community, you will find it as well. Okay, before we start, can I ask you just for a moment, open your cameras? I see a lot of people already open it. Thank you so much for this. But yeah, like now, I would like to see as many as possible because during an online event, we do the screenshots that could be similar to in-person event when we do picture. And thank you again so much for joining us. So seems now we are good. Okay, one more. Okay. Okay, 1, 2, 3, smile. Yes, so cute smiles. Okay, let me save it quickly. So I definitely won't lose this part. Here. Yeah, good. Let me try again, just in case. Okay, I see one more person. Now, how I can... good. Yeah, 1, 2, 3, smile. Perfect. Even more smiles. Yeah, I like this one a lot. Okay, now let me start with our presentation. Oh, okay. Oh no, let me do one more. I now see more faces. Okay, let me do just one more. This last one. Promising. Okay, and yeah, thank you so much. 1, 2, 3, smile. Yes, thank you. Thanks again. And you're free to remain your camera to be open so I can see your faces and your reactions. And I also can see you while I'm presenting, so that's very rewarding for me as well. Yeah, okay. Now, what we're going to do, we're going to start. Let me do this quickly. Now I can see a lot of faces at the same time. Amazing. Now I'm going to start slideshow and I'm going to share this window. Okay, perfect. And I put all of you guys here. Yeah, perfect. I like it. So show my screen anyway. Welcome to session 1 of Design Pattern course. First of all, a little bit about myself. Now I'm VP Lead Software Engineer at JPMorgan Chase, and I'm really proud to say that I extravolute. I worked there 3 years and built a lot of things that people enjoy around, and I'm really happy when you enjoy some things that Revolut is doing. That's why I'm proud of it. I also Yandex, and overall, it's like 10 years of experience. It is a very high load system when like a lot of people at the same time doing requests. So designing and doing it in the very supportable and maintainable thing is my passion, because at the end of the day, it's me who will deal with it if it's designed wrong in the beginning. Now, before we start to dive deeper, could you share your thoughts? Why do you think we need design patterns at all? So you've joined this course, you think we may need it, you think it's helpful, but could you share with me why? Maybe one or two people. Just raise your hand. Yeah, Ariana, yeah, is that correct to pronounce?
Yes, that's correct.
Mm-hmm.
And the first thing that comes to mind is just that it becomes easier to reuse code.
Mm-hmm. Mm-hmm. Yeah, indeed. It's a good answer. And Avnita, yeah, Avnita?
Yeah, I thought maybe for performance reasons, optimize performance.
Mm-hmm. Mm-hmm. It's good thinking. And actually, I will share something on it today as well. Yeah, thank you. Okay, anyone? Any more? Okay. As the code grows, it becomes hard to maintain. If there is no design patterns. Yes, that's also correct. It's very good. It's very good comment. Not reinvent the wheel. Yeah, you read the book. Yeah. Okay. Let me continue with my presentation. So, for feasibility, yeah, to actually simplify things. So when we do designing, we can use visuals. And when we say like, oh, design patterns, if you go through the book, which we'll use as a reference to refer to materials, yeah, there are a lot of diagrams, and it's not necessary that you would use the same diagrams, and I will share today why. But it's more about, I liked it because it's more like a visual exercise. And if you can even see visually in your head how your different classes interact, or how your objects or how your function interacts, that's good exercise to do these visuals and do the structure, like understand the structure. So stable software, this is something, as I said, if it grows, then it's harder to maintain. So yes, patterns allow us to build more stable software. So faster, it can improve time to market on new feature. It actually can improve because you wouldn't spend time to overthinking. You can agree on the same things with engineers because you know the same terminology. The same as I say about common language. So you can use pattern language. So you can, instead of discussing how to implement think, you can say, okay, this could be this pattern, and then you can go to details like which one and why this one is not one. So Catherine, I'm sorry that you're leaving us. Please join us next session as well. So you also can easier contribute to existing code base because you already know that these follow exact pattern. And you also have cleaner architecture to provide updates. So that's like at least two things that's coming to mind. But when you mention your ideas, you're also right. And let's look at this in a little bit of history. How many patterns invented by Go? It's 23 classic design patterns. We can cover them all I already have material to cover them all, but also we're building this course to be very interactive. And if we think at some point that you want to jump to more high-level design patterns instead of go for all classic, we also can do this. Keep in touch with this course, give me feedback at the end, so we can also see how we can leverage these classic patterns. And I'm going to share why I'm talking about leveraging these classic patterns even more to today modern design patterns. So let me explain the history of these classic patterns. This book, Design Patterns, it appeared in 1994. So at this point, even Java language was only in the beginning of coming. It was 1993 then Java first ever version we released. Python also has just been released as a language. Before this, everyone used C, and C++ came as very shiny new language. And there was even no like popularity of Java and Python at this point. And think about it in this way, it actually it takes maybe a year to write book, but it takes like 3 years to publish it because you send it to editors, because then you do peer reviews, because you do this and this and this, and that takes at least 3 years to release the book. So when you think about classic design patterns from Wolfgang, it's something that they wrote in 1991, 1990. Yeah, so you can think that all their experience was based on 30 years of what was happening in industry, but it was 1990. Yeah, so keeping in mind when you think like, oh, I need to learn and I need to be aware about all this Golf classic pattern by heart. No, you don't, because they were written at these ages, which is ages ago. Yeah, I hope you feel better after this. You don't have to like memorize in your head all these 23 classic patterns. That's my first ever message, to make your life easier. And we will go through patterns that's really good to understand and really relevant today. So my ultimate goal after this course, I'm fluent in these design patterns. I understand them very well. I can drive discussions. I can drive design. This is my goal. Please help me to achieve it. Yeah, okay, let's go next. Java actually coming, and apparently the ideas that were written for C++ goes very well for Java language, because C++ and Java both object-oriented languages, and patterns becoming very, very popular for Java developers. And that's how it's coming to the amazing book, At First Design Patterns. It was very, I read a bit the story, and it was very engaging project for people to write designs for Java, like course certifications. And people who wrote these books, they did a lot of contribution to tutorials to give people certifications in Java from Sun microsystem, if you ever heard about it. And apparently it's continued to evolve, it's continued to be popular. Java language is not fast in updates, but it's backward compatible, and it could be released at any platform. It's like whenever you want, you can launch Java applications. So Java became, by 2019, by 2017, 2019, Java already is the most popular language on the market. Could you manage it? And that's my very good answer to interview. It was my very good answer to HR interview. Like, why did you decide to become Java programmer? It was like I was postgraduate, and it was very easy for me to say, oh, because it's the most popular language on the market. That's it. Just go to dashboards, just Google it, and you will see that it's Java. So that's why I picked up it. That was easy for me to say. I also liked it much more than C++. I picked up it. And it's already had very good support from JetBrains with IntelliJ IDEA compared to support with C++. And I was lucky even to try C-Line, which is also JetBrains things. That's also could create a project in C++, but still, I really like Java after exploring and playing with C++. So that was my personal choice as well. And I had friends who were reading a lot of books in Java, etc. And even this had first design patterns came from my friend. But I was lucky to be in technical university. That's why I'm here for you to share it with you. Yeah. Now, 2019 design patterns. That's very cute website. And you can also find a lot of patterns explained the same Java, but also a lot of different languages who kind of implemented this object-oriented idea to achieve this pattern. From my experience, other languages contributed in not really feasible way into this. They just write the same ideas on their languages, but you can also learn from this website if you have another language, if your primary language is another language. And because of it, at first, already decided to little bit redesigned and refreshed the context. The only main difference between this 2004 book and 2020 is that 2020 colored. I'm serious, it's just colored, and that's make it more beautiful than the first one, but I can assure you the content is the same. Yeah, it's just second edition with like kind of, they also referred to Java 8 features, because in 2016, something like this, finally Java 8 released this lambdas and anonymous functions that allow you to do a bit more functional programming in Java. I will go to this again. But yeah, that's what you know about timelines. These timelines are important because I'm going to share other timelines as well. And I hope you will have a clear picture of what's happening in languages in general. So it's the slide that's happening in my second edition of this course with this introduction to two different concepts. The first one is object-oriented programming, which was the first ever version of Java, which was C++ before, again, lambda functions and C++. And another concept, very important one, which is data-oriented programming. And I will share on the next slide with you timeline so you would understand why it's important. So let's go through object-oriented programming. Your first-class citizen is object. And before even I go next, any of you know what does mean first-class citizenship? I wouldn't say it's good. Like, it wasn't easy for me a few years, like many years ago when I first heard about it, like to understand what is it. I asked a lot of questions, what is it? Any of you like can raise a hand? Do you know what first-class citizen in language? What does it mean? Okay, that's fine. No worries. Let me explain. So that means that what you actually operate in your language. And again, when languages only appeared, there was, maybe you heard about it, procedure languages like Pascal, like very low-level language, QBasic. So you could do procedures there, and not even functions. That's a little bit different in it, but you would write procedures, and that's it. Like you just say, get input X, and that's you can return outcome Y. That's it. So they were like low-level languages, and then functional languages, for example, Python appeared as functional language, where you like could give function and then you can return function and put as a function as a result. This is important as a result. And yeah, you can create function without having anything. That's important. In procedures languages, you can create procedure without having anything. In functional language, you can create function without having anything else. And in object-oriented language, you can create object. So every time, these things that you can create without having anything else, that's called your first-class citizen in this language. So in Java, you couldn't create function without creating object. That's why an object is first-class citizen. Your first ever entry point to your program when you say like launch me program in Java is object, which is like class object, and the main function, your entry point, for example. If I'm correct, there are other languages, there are also like first ever function main, but if it's object-oriented language, this function part of some object, and it can't be done in another way. This is how the language designed. Why it's important? Because of it, there are a lot of things how to interact with objects without being able to return function as a result, for example, without ability to create function like just here without having object with function related to. So that's important thing. That's basically came and leverage these patterns for object-oriented programming. Yeah. I hope today you can say today I've learned just after this one. So like different languages, especially many years ago, they wasn't that easy. That they couldn't that easier to exchange things between each other. Like if one language is functional language, that's it. It's purely functional language. If Python was purely, at first ever edition, it was purely functional language, and Java was purely object-oriented language. So that's why this coming as a concept of object-oriented programming. But today, apparently, these languages, they came through evolution. And now they actually exchange a lot of things with each other. Now you can do objects in Python, you can do interfaces and hierarchy in Python, and also you can do functions in Java. You can create anonymous class, but you already can forget about anonymous classes. You just use them. And I will give you even more examples next. Please hold tight. I understand it's a bit it's a bit more introduction. So in object-oriented programming, you create an object, and then if you need another object, it should be child of this object. And in Java, there is a first ever object, which is called literally object. That makes sense. That made sense for designers of this language. And then you create everything from this object. Your first ever created object will be implicitly inherited from this object in Java. So that's how it works. And you control things through hierarchy. And then also compiler can help you to do a lot of rules, depends on objects. And when these objects came, we created solid principles. I will cover them as well later, but that's how we create objects to be robust, to be like good objects, to be maintainable. And I will explain it as well. But new thing is data-oriented programming, which is more simple, more consistent, yeah, more concise. And this is where you separate data and functions. Functional programming is good in it as well. And you can validate a lot of things because of lambda functions during compilation. So it's harder to make mistake. It's also important. So let me go to milestones. as you see before, okay, let me go again. So second edition, 2020, which including features from Java 8, Java 8 2016, if I'm correct. But you remember that it takes 3 years to publish book, so that's why it's books a bit behind. But still, I love books as they like finally collected all ideas in one place. I love book. Now, 2021, release of Java 16, 17, and records, and some concept as sealed class, which is similar to enums, but more powerful. They came, finalized, and released. And that shifts the strategy from object-oriented behavior to this data-oriented behavior. Then, LTS means long-time stable release, Java 21, 2023, just 3 years ago. That's coming as record patterns and pattern matching. And that's can help you to write easier, a lot of different business logic and different ways your code may be executed with pattern matching. I first learned about this pattern matching in Scala. And back then at Yandex, I was Scala backend software engineer, so I really liked pattern matching from Scala. Scala was a lot about being object-oriented features from Java, but could be purely functional language as well, but unfortunately it didn't succeed. It didn't have success, didn't have good adoption in the industry. So today, my primary language is Java and Kotlin. Now, Kotlin also came as a very good thing for mobile development, but then it became more robust, more good, and finally, by 2024, it came as a big adoption on backend. So now we have two primary JVM languages on backend, Kotlin and Java. Yeah, and then 2025, it's coming with even more features in language with Java, and also Java had very popular and have very popular framework Spring Boot, and then this framework coming with even more things to pilot data-oriented programming first approach. Yeah, okay. Finally, let's go to first strategy pattern. And when we will go through the pattern, I also will give you a lot of examples how you can think about this pattern, even if your language is not it's not Java, and if it's not even object-oriented. And by the way, can I ask right now, could you raise your hand if your primary language is not Java, or if you are learning, but it's not Java as well? Yeah, okay, good. So, no worries. This book have examples in Java, and I will talk, of course, about object-oriented programming. However, this is about learning the concept and then apply the concept to your language. Oh yeah, by the way, during my explanation of strategy pattern, you can share what is your language. So you will see how many mind-alike mindsets you have here. Yeah, please share during my presentation of strategy pattern. So, strategy pattern. In this book, I have cute ideas about building game with stacks. So I love this book because examples can start very well in your head. And then if you would like to exchange some ideas with another one who read this book, you remember this stack pattern. And then it's easier to continue discussion because this is sometimes very hilarious examples in this book. However, I like them because it's easy to memorize them. So we created a game that's operate with ducks, and these ducks can quack, they can swim, and we can display them in our arcade game, for example. Yeah, and we say like, oh, let's have a mallow duck, which is like the most popular duck if you go to lake. This is mallow duck. If you don't know, redhead duck. I've never seen in UK. I don't know. Maybe I've seen, but anyway, this is less popular duck. But why wouldn't we have more ducks in this game? And then product come in and say like, let's do rubber duck. And developers say, okay, we have interface ducks. We already kind of very flexible. We can implement whatever duck you want, which is great. They can quack, they can swim, and rabbit duck also can quack and swim. And it just like funny squeak when rubber duck is quacking. Yeah. Okay. Good. Here. Okay. I see. Mine is C#, Java, and Scala also use object-oriented approach, and Kotlin also use object-oriented approach. You actually can create objects in Python. So when you look at this, any of you could raise your hand and share with me what object-oriented programming principle were violated here. Maybe someone could see. It wasn't in book. It was something that I by myself would recognize, and it's like a bonus question. So there is, don't repeat yourself. If Muller duck and redhead duck, no, they swim in and quack in a different way, and rubber as well. So not yet. Don't repeat yourself is not yet violated. And also don't repeat yourself, just software prints, but not object-oriented programming prints, but just like to have good software, don't repeat yourself. So there is a solid principle, solid principles, solid responsibility. Single responsibility principle. Yeah, I was. Yeah, thank you. So single responsibility. That's about like my object is going to do one single responsibility. And I love this principle because you also can, right now in the era of microservices, you can apply this principle to your service. My service should be small. My service should do single responsibilities as less responsibility as possible, as single as possible. So this very wide principle, not necessarily object-oriented programming, but it came first from object-oriented programming, which is mean if you create class like duck shouldn't print theirself as a duck shouldn't export data about itself in a CSV file or something like this. So for this, you write another class which is exporter, for example, very easy example. So duck on this plugs in, but doesn't do like export to PDF. Yeah, this is single responsibility principle. Open close principle, which is mean if duck has name, you can't change this name, it's closed. And if duck like has already this behavior clock and theme, you can't change this behavior, it's closed for you. So which is mean there is interface duck that can be and quack. So that's your interface. So you just open interfaces, but you close implementation. This is open closed principle. Nothing really like no rocket science. Very simple. Least cost substitution principle. If you try to Google for Wikipedia original idea, it will show you some math. However, if different ducks will do absolutely different quack methods, and if one of them can fly and another can't fly, they can't be parts of the same duck. Something like this. Yeah, rubber duck can fly. That's why this principle is actually violated here. So this is like another idea how you could suppose like it's not going to do great because you can't do even this inheritance. Another idea about it, if you think about rectangle and if you think about quadrat, which like have only one side because all sides are the same, they also can be like rectangle couldn't be part of quadrat. They also they have to be separate, and maximum they can have shape as a parent. And it's again for object oriented where you have a lot of things in hierarchy. Interface segregation principle. It's again like having an interface as the one that segregate all small things and close implementation, so private functions. So that's basically to learn how to work with public and private functions in a very good way with this thread. And dependency inversion principle, it's some principle that's allowed us to create factories and allowed us to, so if DAC is going to be exported in PDF, DAC shouldn't create PDF export, like PDF exporter by itself, something like this. That's how I can explain it. There should be factories that create both of them, and that there should be an orchestration, something like this, that's allowing to print, to export all traces and information about this DAC. That's playing in this game to like PDF information to like report about this DAC. If you have any questions so far, please raise your hand. Yeah, so yes, that was Lisk's substitution principle, which is mean like you can't basically use the same. Oh, thank you for the reaction. Yeah, you can't use the same parent when you build this hierarchy. Okay, so what pattern has been used here? That's a good question. So we create interface, and yeah, I actually had one more pattern in my head. So yeah, anyone who read next, could you guess which other pattern you can think it was a part of strategy? Okay, I'm going to give you an answer. Again, from my perspective, it's touched another pattern that's called decorator. We will look at it in next sessions as well. So what's happened, like you decorated dark with different behaviors. So when you come to decorator pattern, you would understand what I'm talking about. This is more like if anyone was reading the book and went further than strategy pattern. But the part of strategy pattern, it's also remind me really decorator pattern as well. Like I have an object and also I can decorate it. Okay, strategy pattern. So now, as a definition from the book, the strategy pattern defines a family of algorithms, encapsulate each one and make them to be interchangeable. So as you see, it's not only about objects, it's about family of algorithms, and you can apply this as it is, not only to exact program, to exact language, but also you can think about in general, in your microservices architecture, when you have a lot of services, they interact with each other, you can think, okay, which one is family of algorithms that's good enough to be in one service, and how we can separate different functional, different business logic to different microservices. Not only low language pattern, but you also can think about it as a high-level design pattern. So this is example from book. This is here how we implemented fly behavior, clock behavior. And we said like duck is going to invoke different classes. And I will share with you example in Java in the same way. But then I will share with you how you can think about it on the high level design. Yeah, okay. So design principle encapsulate different things, which is because they are implementation, so they are encapsulated. Favor composition over inheritance, that's happening every time, everywhere. This is the main takeaway. Okay, if you see my screen change, I'm going to change it back. So favor composition over inheritance is actually, if you go to language that support inheritance, whenever language it's not necessarily Java, always think how you don't have to do abstract class that then implement another like and do a lot of implementation. Always think how you can do composition. So to explain this concept again, yeah. Okay, thank you for joining. Please join other sessions and you can look at the recording as well. So basically, when we were saying that we now have composition, so then we say that duck have fly behavior instead of having fly method in duck, we composite behavior. So that's what it does mean about composition. The same about quacking, instead of being the method in duck and being inherited, it's composition, which is mean it could be here, but it's composition. So it's much more like you can do a lot of things. So you can say that rather duck never ever implement fly behavior. So it haven't inherited it. It's could compose it and put it in their part, but it doesn't have to do this. It also can say like there is no way to fly, but at the end of the day, it may even do not. You can even have it in more like interface. I may implement it, I may not implement it. So that's how we do this, and also program to interfaces. Again, like there could be interface instead of being implementation, like some default implementation to fly, like default, like I'm not flying. Instead of it, you do interface, flyable. So I think it's interesting example how to approach different design challenges. So you can think about it. Okay, I have an algorithm. Should I put it as a separate thing? Should I put it outside of object as separate thing? And especially now with functions, it's much easier. And I'm going to show it next. Interface. Now you also can put it in function. And you can do specific implementations, which is, if it's object-oriented programming, it's different class implementations. But if it's functional language, you also can do few functions. So it's easier refactoring at the end of the day. That's like a bit strategy to figure it out if you need to apply this pattern. Very straightforward example. Just instead of duck, we said there is payment, and we said that payment could have payment strategy. So instead of saying like my payment service do pay, we say like my payment service could do different payment strategies. So that could be credit card payment, PayPal payment, and depends on payment strategy. We say that we can do it. Yeah, but now I'm coming back to point of microservices. You may decide that your payment service as a service shouldn't decide what exactly strategy it has. You can even go wild and say like every different strategy will be their own service, because like every time I need integration with vendor, I don't want integrations to be like interchangeable with each other. So I want less dependency on the same service. So now you can think about it on higher level, on designing system as well, like how you can do it with different microservices. So that's why I think strategy is a good pattern, not only on low-level programming where you decide how to design your program, but on microservices design level. Yeah. Testing. Okay, there is example that you also can think about it. If you don't use external libraries to test in your applications, you can have these examples and think about it. So you create HTTP client that's going to send HTTP requests. But when you test your application, you create something like stop client, which is not going to send your application, your request anywhere. It just helps you to do predefined response. It's also kind of strategy that you can use as a pattern. And now you can reflect, like, if you have anything like this, if you exchange like real behavior for some mocking behavior for your tests, then you already use this strategy pattern. Then you already implement it in your projects. Okay, yes, that's some user service that you give, etc. And now you can test, and you know that you do request to payment client stop. Okay, you can look at them more in this presentation. I will share it as well. Now we come into data-oriented programming. And now, as I shared all these things that's changed in last year, I'm going to share with you how Java changed. And feel free to go then to any AI tool you use and ask them, okay, this is my language. This is, head of design, head first design patterns. Now, could you rewrite this example from the first chapter for my language? You're free to do this. And I think today is the most interesting time to learn than ever happened in the history, because you also can it's easier access to generate ideas as well, to leverage tools to help you to learn. So for my example, I can say, okay, let's look at how it's changed for today's 2026. And what we can see now, interface fly behavior is going to be something that's called sealed interface that has few records. So why it's cool? Because as soon as these records are there is no more, they're very easy to exchange between this behavior. So now we say we can fly with wings, we can be rocket powered, and we could not fly at all, no way to fly. The same of class behavior. It could be just like normal duck. It could be funny squeak that we can get from rubber ducks, and it could be like no behavior, mute, because we may need these ducks as well to play with them. So now, instead of having Java object duck, we have records in Java. And these records are amazing things, because before you should write like get and set, and then you say set is private. So no one could do set for me. And then you would use some frameworks like, I don't know, Lombok, because it can generate you these things, because you just started to write get and set all the time. And then there is a pattern builder that we can look at it as well. It's part of these design patterns that allow you to build objects and make sure they are immutable. So why immutable is important? Anyone operate with languages with immutable objects. Anyone already like, I know that objects, I know that data should be immutable. Anyone could raise your hand why it is important? Yeah, we have Victoria. Yeah, do you want to share your thoughts? Why do you think it's important to be immutable for any object that's happening?
It's good for multi-threading systems. That's thread safe.
Yes, yes, for many. Yeah. When you operate these few threads, it's important. So we operate with many threads because when we receive request response, we want every time to be in their own thread. That's why we think that threads are very important, and that's why immutability for objects is important. If you have objects to be mutable, and if they could be changed somehow unpredictably in your system, it will be a nightmare for you to debug it, to look at logs and try to understand what has happened. So in language industry, there was massive shift to give you tools to create objects to be immutable from the very beginning. So when we create objects, they are immutable. Now, a lot of languages support it. If you're not sure about language that you use, again, go and check how to create immutable data structure, not even object, not necessary to say object, but immutable data structure, immutable data. So you make sure that it's safe to operate with this data, like at least exact this record couldn't be collapsed during the execution of your product, of your program. Okay, so this is how it looks like in Java 2026. Now, if you say this is our simulator of ducks, that's going to perform flights and perform clocks. And this is pattern matching that you see, switch case with this amazing thing that's called pattern matching. I was touched in Scala and I was like, maybe Java one is also implemented. And now I'm here and Java implemented this one. So it's an amazing thing to have in your application because as you see, I don't have to check which one is which one. I just operate with, just say which one is which one. And the compiler can compile it. And they also, I don't have to say which one is default in case something is missed. That's what I had for years. Like I should have to make sure there is a default branch because it could be changed and compiler couldn't not notice. But now there is no default branch because everything already precompiled and everything is safe. Like there couldn't be like, it couldn't be another engineer who add fly behavior for like, I don't know, wings rocket power. I don't know which one could be another one. Jumping, I don't know, fly through jumps. And then like forgot to add here in this action because trust me, there was so many production problems when people were just forgetting to add default branch. They added something, they changed things that they needed to change, and they forgot to change things they didn't need to change at this point. They just forgot. They just didn't know that these variables are used in other places as well. And there was real production bugs and money loss for companies because of this default branch. I saw it by myself as well, and it was very easy to do this mistake as well. So yeah, right now we don't have to think about it when we use this syntax sugar. I can name it syntax sugar. That became much more safe. And we come into point of performance. We mentioned it today. So when we use all these data-oriented new features from Java language, we can allocate them in memory, and that's perform code much faster. Thread safety, absolutely correctly that Victoria said. It gives us important thing that no other thread would change data simultaneously. So if you think about, again, something like payment system, right? If another thread change the amount at the same time, just because, I don't know, second request is here, it will be critical. It will be a very bad issue. We now have this very good separation. Duck is here. So one of the important things that I see with data-oriented programming is that's now data separated, right? So we have now Duck, which is our record with data, and behavior, which is line and quicker, and we can switch between them, which is very good. And this is very good separation. We have objects for behavior, we have data structure, and we have functions to do implementations, to do something like, again, like to do behavior. Yeah, and you don't have to do instance of, again, like you don't have to check the inheritance class for Java anymore. But I think that many languages right now also going to reuse these ideas. Yeah, okay, let's revisit payment strategies that we looked at, and again, how we can rewrite it. Now it could be payment strategy interface, which now have new keyboard and then its records. And again, I hope it looks more familiar for you right now if you use another functional language, because now a lot of concepts, again, we can interchange them. And this is how it looks like with switch case. Now, I'm going to share with you Kotlin, but again, feel free to play them with your language. And again, you can see like how it's changed from language to language. And if you also had experience with your language, it's also will be very good. And the important part, if you're trying to learn new language, experiment a lot. Like, okay, this is the strategy, this is a pattern. Now, how I would implement it in this language in the best way, like what syntax sugar and what hooks from this language that I work in this, I can use to basically to figure out how to leverage strategy pattern. And you will get very good answers today. So for Kotlin, it looks like field interface, then data class, and also you can experiment with class and with data object, because it's more different things that Kotlin gives today than Java, because they could get advantage of writing everything from the beginning, but just using the same Java machine. And this is how it looks like. Now, again, it was record in Java, but here it's called data class duck. This is val name string. This means that it's immutable structure. This is not nullable thing. So again, like if you have your own language, just experiment how it will look like in your language. And if you go with these concepts in your head, then you build in your structured mindset how to approach different problems. I hope that will be a good exercise for you. And how we would perform fly. So again, we switching easier between them. It's instead of switch case, here is ban is. Yes, so this is how it's a bit different in this language. And also what's happening in Kotlin, and again, like if you're from functional world, I would like to share with you how many other things you have because you're coming from functional world. So for example, here you can say, as soon as we configure in our flyer behavior, we also can apply some configurations, and we can provide it here. Yeah, which is like allow you to play between data and between functions, and we didn't have these things in Java. Another thing, like this select keyword, again, like it's allow you. Maybe user can say which one is behavior they want from command line, and then you quickly play with it. If user have choice, then let, and then do something with it. And again, like you do it on fly. You do a lot of things on fly when you have functional language. Has been object-oriented programming, you just don't have this choice. You couldn't do this, but I put in these examples for you so you can see how it could be transformed from object-oriented language to functional-oriented language. So this is, and it's okay to do it like this here because we know that it's a small part. So that's how we can use it. Another thing in Kotlin is popular, like instead of printing every time, you print only when you executed something. So you could use like the key name word also. And yeah, builder pattern, as I said, builder is one of object-oriented programming patterns to construct object. However, in Kotlin, you can easier say how exactly to build it without any builder's pattern, which is very powerful. Yeah, okay. So again, for functional work, I've put here TypeScript examples. This is how would you define behavior when you use TypeScript language. This is fly behavior, this is clock behavior. Seems less wordy, right? Few less words. And that's, you still have interfaces. You can define if it's read-only. Like you saw, you don't have to do it in Java or Kotlin anymore. You don't have to do it to say that it's read-only, but here you have to say it. But again, like, because now we have like things that every language is targeting, maybe that also will be there. I can speculate, I don't know. Now, in TypeScript, you will say there is a constant that's going to perform fly, and this is very cool thing to explain why functional language is different to object-oriented language, because you didn't have to create an object to create a function. And this is Lambda, what you see here. But again, when Java came, when C++ came, there was no concept of Lambda at all. This was dreams of people who designed these languages, but they tried to do just easy language in the first place. And only after so many years, they figure out how to do these Lambda functions as well. While like other languages thought, oh, it will be easier for me to do it with functions in the first place. That's why first citizen. And this example that we can see in TypeScript, and definitely Java copied it in last version of Java. You can see the same switch case. But yeah, so this is something I was talking that Java, you don't have to do it anymore. You don't have to break anymore in Java, and you don't have to do default strategy anymore. So that's now leveraged with few shiny things that I've heard. But when you see this one, case break, case break, case break, this is something we had to do years ago as well. And if you forgot to say what to do with default, you may broke the whole project, the whole program. and one deploy, you can break the whole service. Yeah, okay. At the end of the day, we say how we can write some Quark implementations, and how we can perform these quarks by using libraries. So you see, like, the concept a bit different because it's different language, and don't hesitate to play with your language to share ideas how you would do this in your language as well, in Slack as well. Okay, I hope it wasn't too many coding at this point of time. So when you've now learned this pattern, I hope you're still here. Could you please share with us where did you see this pattern by yourself in your programs? You can write in chat, but also if you feel enough power, I understand it's 8 p.m. right now, and if someone is joining from Europe, it's already 9 p.m. for them. Yeah, okay. But anyone brave, Let's go, let's breathe. Yeah. Okay, 1, 2, 3, 4, 5. Let's go then. Okay, I would skip comparison. There is a website where you also can experiment with patterns. So if you go there, like, you will see these things, you will see like how to look at different strategies as well in terms of how it's explained here as well. Yeah, I'm going to continue here. This is just one more resource for you to learn. Now, system design, the same as I shared. Now you can see it quickly. Now you can see it clear as diagram. Like, you may create different microservices for different payment strategies. Again, like, I don't know what business you are coming from or what business you would like to work for, but it could be applied as idea for different businesses. Good example, even with notification services, like, think about it, you have customers and you want to notify them, and you may want to give them SMS, you may want to send them a mail, or you may want to send them push in a mobile application. Even in this case, it may be a good idea to do a few microservices to have this one. Yeah, other things, as inspiration from system design. So dynamic routing, which is mean there are a few different strategies to route the traffic. It could be round robin, which is like just go one first, second, then third, and then if you have the fourth, go to first as well, go to first again. Then you can say it depends on geography. Then you can say like other things, hash-based routing, etc. So that's good idea. Load balancing, also good idea to think about strategy. I think right now we more like operate through YAML files with load balancing and with strategies, because there are a lot of things on the market already in Kubernetes that allow you to pick up the strategy, but still, like, it's also different strategies. Cache strategy. This is when you have an application, it interacts with database, but you would like to improve the performance, so you pick up that. If request has came to me, I can try cache. If there is no cache, there is no data for this request in cache, then I go to database. So different strategies. And this is a good example. You can even, I think this is the best example as well to try to play if you want to create some app and see like how you would change your repository level. Depends if it's cache or if it's a database you interact with. And I think it should also be good for any language as well. Then return mechanism, this is stability pattern. Also could be different strategies, and the sharding of data. Yeah. I'm trying to be a bit quicker now, but again, if you want to ask me any question, please ask, because we're almost here. Yeah, okay. Any questions so far? Okay, I see no questions but sleepy eyes. So we now came through first pattern, and if you see, it's not only a low-level design, but you can think about a system design, and we can apply it to different languages, and we can experiment in different languages. Again, reference for design patterns, specifically these 3 blocks. These examples you can find in presentation. I'm going to share it soon. The Slack channel I'm going to use. Let me quickly check the Slack channel if I already created this one. Oops, yeah, just a moment. Let me see if I can. Okay, yeah, I can find it here. So, then, yeah, design pattern course. We have this channel. Yeah, let's just use this channel. I'm going to put it here. So that already have canvas with all materials as well. This is from first part, but you already can find a lot of things there. And yeah, this time you can join this Slack channel, and also if you can publish examples in your language that wasn't shared here, it will be great. Yeah, so let's go and play around it. Yeah, could you please clarify what is a repository? When is it for caching? Is it for this one, the question?
But from the first minutes, I thought maybe you shared in the beginning repository.
Repository for examples, you mean on GitHub?
Yes.
Okay. Yeah, I will share this one. I didn't add examples here yet, but I will add examples there as well. And I will update slides a bit. I want to update them. But I will put it in the channel. So please join our Slack if you are not yet there. And you then can follow to Design Pattern Course channel. And I will put the link there. Yeah, okay, so it's like general recommendation in patterns, keep it simple. But yeah, now I'm going to stop recording. Just a moment. Oh, thank you so much. Thanks to you for coming and joining. Now I can start. Where I can start. Yeah.